Now we're going to move into plotting reflections on curved surfaces, and we're not going to go for the full construction on this one quite yet, but I want to talk about this and get you thinking of draft views, basically. So thinking about these views from when you start thinking about plotting reflections, I want you to think about them in individual views, and then you're going to combine those views, like a side view, a top view, a left-hand view, for instance, to help you plot and predict where the reflections will be in perspective. So let's just look at this scene for a moment. So in this scene, I've got a matte cylinder, and I've got this ball, tall cylinder here, stripe on the ground. Now we should talk about our environment. Our environment, we're out on all these settings. The previous boxes are just out in a classic desert scenario. So imagine like dry lake bed, a low ring of mountains around that lake bed, and a clear blue sky. So I would want you to estimate and think, where would you see the reflection of just the environment? Let's not even worry about these objects for this example. Let's just think about, okay, the ground and the sky. Okay, we have this. There's no radius on this. It's just a straight up cut cylinder. So on that matte surface, where would I see the reflection of the sky and the ground? So think about that for a minute. You can pause this and then think and try to predict where would the sky and the ground be. And, would we see the mountains on there? That's a nice thing to try and think and predict. Now I'm going to give you the answer. And let's draw first a little side view. I'm just going to draw over the top of this. And I'm going to say that that is our cylinder. And where is our eye? Where is the camera? Okay, that's a question. Well, I can actually tell you where the camera is in relation to that cylinder, because I can look at this ellipse on the top and I could say, well, that's probably about a, I don't know, 20 degree ellipse, maybe 20, 25. And had I drawn this, and if I just draw through it, I could probably see that the cylinder on the bottom is maybe like a 35, 40. So if I draw from the middle of my top surface at a 20 degree line, let's see, there's 90, 45, 22. That's probably close enough. Okay, and I go to the middle of the bottom cylinder of the ellipse, and what did I say, close to what looks like about a 45. So about a, let's see, 90, 45-ish, probably right somewhere right around there is our camera or our eyeball for this scene. So now based on that, I can actually start to think about the reflections. Okay, and I can look at this and say, well, here it's hitting this vertical side and it's bouncing off at an equal angle. So I'm just going to predict that angle out, something about like that. So that's where it would point down to the ground. And then here, if it's 20 degrees one way, it would be 20 degrees the other way. So that right about there looks pretty close to being equal angle. Again, just estimating that. If I had a protractor, I could measure that, right? So what's that telling me? Well, that's actually pointing up to the sky, right? It's not pointing down to the ground. It's not going down, it's going up. What's up is the sky. Okay, and what about this side? Well, anywhere I draw, even all the way right up here at the top, it looks to me that equal in, equal out is going to point right down to the ground. So I'm going to say the sides of this cylinder should just be reflecting the ground. Oops, let me grab a brush. Should just be reflecting the ground sort of right around here in our scene. Not even getting close to the mountains. See where it hits the ground right there? And that was right at the very top. And that was on the side where it hits the top. Now, anywhere across the top, all my line of sight rays are going to bounce up to the sky. So I'm going to guess this is all sky, and this is all ground. So So let's see what we have. Sky and ground. Excellent, just what we predict. Okay, now what about the placement of like where is the ball, for instance? So what you want to start to do to predict those kinds of things is you want to start to think about these scenes in top view. So if I had my cylinder, let's see if I can draw a better circle, a little bit better, and I thought about this in top view, and I knew my camera was actually a little bit off center, so it's sort of in line over here. Let's see, how far away was it? You know, if I had the right proportion here, we could start to guess that it was like maybe 1, 2, 2.5, 3 diameters away from this, maybe 2, 2.5. So let's say the camera's right out here somewhere, and the ball was kind of in line with this side, and it was maybe, you know, it's maybe short of 2 diameters. Somewhere right about here is our ball. So if I look at my sight lines, what you want to start to think about from my camera, so right about there, that's kind of straight back almost at me. Let's go a little darker with that so we can see it. So I'd say right about there, equal in, equal out. I mean, I don't have a perfect circle drawn there, but that's going on to the side of the ball. So probably right about in here somewhere, and it would hit, and it would bounce, and it would point towards the ball. So I would say just left of center. So based on this, there's center line, and there's my center line of this guy, right? Actually right there from our camera would be center line. So I'm going to say, oh, just to the left of center, somewhere along that line is probably where the ball is. So it's somewhere there. I don't know how high up and down. If I went back to my side view, okay, and I found my camera again, and I thought about, and I knew where the ball was, if this was all accurately drawn, you could just start to say, oh yeah, probably, yeah, right up in, maybe up in there somewhere is the height. So if I put those two together and say, well, it's along this line, and it's, oh, maybe, you know, guessing, it's probably going to be squeezed a little bit. We'll talk about that in a minute and why that happens. Oh, I'm off a little bit. That's where it actually is. Not bad. The height was pretty good. Again, not drawn accurately, the proportions, etc. But yes, it is a left of center, and it is, you know, a little bit higher up. So pretty close. That is what we're going to move into next. Most importantly, what I wanted you to think about here was sky and ground, and where is your line of sight bouncing. The classic thing, I've shown this to classes many, many times, and not given them any information, and not even had the cylinders, the stripes, or anything, just the matte cylinder in this desert scenario. And I've said, okay, look at the environment around the object, now predict the reflection of the environment in that cylinder. And I can't tell you how many times you see reflections like this: mountains, ground, right, that sort of thing. And it just doesn't happen. It's not a vertical horizon, it's a horizontal horizon. This doesn't even get close to seeing, our line of sight does not bounce that far out into the environment. It really only sees what's around it here. And then, you know, this is all sky. Okay, and then this is just all ground, no horizon. Okay, if the cylinder was taller, then yes, we would start to see the horizon. Okay, because then our line of sight would bounce out to the horizon. In fact, that's a good thing maybe to talk about, is where do you see the reflection of the horizon? Well, the general rule, if it's this kind of simplified environment, wherever your line of sight bounces parallel to the ground, okay, this is to the ground plane. So let me do a little schematic for you here. This will work. Let's just do this. I'm going to redraw my ground plane. I'm going to draw a tall cylinder like this, and I'm going to say our eyeball is here. Okay, now my line of sight is going to come over to here, bounce into that cylinder. This could just be a vertical mirror as well. I see, oh, well, there it's bouncing into the ground. Same, that was just like when the cylinder was short. Okay, what happens if I go over here? Well, here it bounces up to the sky. Okay, well, between the sky and the ground here, there's a horizon. So wherever your line of sight, okay, my eye is on the horizon there, would bounce in and bounce straight back. Wherever, and this is the rule, this will help you for plotting where the horizon line is on a curvy shape. Wherever your line of sight bounces parallel to the ground plane, so this line and this line are parallel in perspective, okay, that is where you put the horizon in your reflection. So, and the reason for that is that parallel lines converge to a single vanishing point. So that means that this line in side view, right, it's just a draft here, this line on the ground eventually is going to converge with this line because they're parallel. And parallel lines in perspective converge at the same spot on the horizon. So if they converge at the same spot on the horizon, that should be where the reflection goes. So it's kind of reversing it and mapping it back up onto your cylinder. Okay, so that's it for talking about some basic curvature, and now we're going to plot one that's a little bit more complex. So let's do that next. Okay, moving right along. Let's talk about a horizontally placed cylinder. Again, you can imagine it's going to be the same sort of thing. Bouncing your sight lines into a shiny shape, and then seeing where they reflect into your environment, and then taking those points that are in your environment and mapping them into the shiny reflective surface, which is all there is to plotting reflections. So you've got to get really good at this if you want to start getting good at guessing where to put your reflections. So you can use these constructions, but when I'm doing them, a lot of times I guess, but this is what's going on in my head when I'm guessing. So you might see somebody who does lots of car designs or does automotive renderings. This is what's happening if they've got a good mental picture of it. This is basically what happens inside the computer as well. So this is the mental image you need to form. So let's talk about this. I have a horizontal cylinder lying in that same desert scenario, and I have a red vertical cylinder here in the foreground. I have a little ball on the ground. Here's my camera. So you have all four views, well, three views here and a perspective view. So this is our camera view in the upper right. Here's the top view to the left, upper left, side view on the lower left, and then here on the lower right we have basically the front view, including the camera in all three views. So with this, we should be able to predict where the reflection of the ball and the reflection of the horizon and the reflection of this foreground cylinder will be in that surface. So all I did there was just highlight the center of that for you. Again, I'll give you this file. You'll see I made a little path layer here. That's a really great one to have. That's just anytime you want to find a vanishing point or radiate from a point, you just take a path like this. And what's nice about it is you can always go back and grab that point and move it around. So if you're going to a vanishing point, you're going radiating point from a light, or in this case from a camera. Looks like I've got one dead one there. I could probably just leave that alone. Needs to get reconnected. So unselect that. And then when I mirrored it, I just mirrored my whole path, put it over to get all these lines bouncing out at the exact same angle, which you'll see here in a moment. So that's how I drew all those lines. I didn't use a line tool, just stroked a path with a small airbrush, or a small regular brush probably. So those are my sight lines from the camera. Now what I want to do in the top view is I don't want to think about the curve. Okay, I'm going to think about the curved surface in the side view, but not in the top view. The top view, I just want to think about this being a straight, flat, mirrored plane. All we need out of the top view information is we need to know the placement of this cylinder, the placement of the ball, and how fat or how wide they are in that surface. So I take the white lines in, and then the blue lines bounce. That's my line of sight bouncing out. So let's zoom in on this top view a little bit. Okay, now I can see that the ball is between this line and this line. Okay, let me grab something to draw with here. Yeah, there we go. I put a notes layer on top. Okay, so the ball here is between, and it's set over to center just a little bit. So I'm going to guess that it's probably centered there. And if I ran the sides of it back, it's probably going to be somewhere about there. Okay, and if I look at this guy, all right, for the big cylinder, well, there's one side here, one side here. So one side is just a little bit past this blue line, so I can just estimate that's where it goes. The other side is showing up not quite halfway between those two, so that's where that side goes. So that's the placement, right? I'm not drawing them on that curved surface. I'm just placing. I'm just trying to find what is the width, okay, of this cylinder in the reflection and this ball in the reflection. Same thing. That's all I care about in this view. Width. Okay, we're done. So now let's go down to the next view. So here in the side view, I have one errant line in there, it looks like, is where is the position on the curve. That's what I care about. So now I've got the curve, and I want to know where does this ball reflect, and where's the height of the cylinder, and where's the horizon line. So we take a bunch of sight lines, bounce them in, bounce them out. Okay, and let's zoom in here, and let's see if I can get this to fit. Yes. Okay, sight lines come in, and they're bouncing out all over the place. But again, it's always equal in, equal out. So that's going up to the sky, sky, sky. This one's right back to the camera. And right about, let's see, this line coming out of here, that one looks like it's going to hit the top edge of the cylinder. So that would be the height. That's the top of the cylinder. Where's the bottom? Well, it looks to be just below this line. So if I go over here, that's just below. That's the height of our cylinder in the reflection. Okay, and then what about the ball? Well, the ball looks to be a little bit, it's right on that line pretty much. So it's going to be a little bit above, I'm trying to pick a different color here. White maybe. It's going to be a little bit above the bottom edge of the cylinder. And then the bottom of it is, looks to be, if I look here, about in the middle between this line and this line. So that puts the bottom right there. So that's the height of the ball. That's the height of the cylinder. Where's the horizon line? Where, what I said before was that wherever your line of sight bounces off parallel to the ground plane, well, this line here, the blue line, is not quite parallel. This is not. It looks like a line right between them probably would be pretty close. Maybe up just a tick. Right about there would be parallel to the ground plane. Again, parallel lines, right, converge to a single vanishing point. So it looks to me like that's going to be a little bit below the top of the cylinder. And that is all we need to plot the reflection over here in the camera view. So I have a couple section lines on here. Had I drawn this, I'd probably have a few section lines on it as well, so that would be helpful. So try to remember that. If you don't know the sections of your reflective surface, you're going to have a really, really hard time trying to plot the reflections across it. So you need section lines. You need to understand all of the surfaces of your shape in order to plot the reflections. Okay, so what's next? Next is to predict here and see how close we get. So what I'm going to do is I'm going to count a couple of these sections and then place those things. All right. So I said that this guy was, looks like in the middle. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right there on that line. Looks to be a little bit off center, somewhere over there, looking at where those lines are. And then how high up? Well, I can, if I zoom back in on that, I would see that it was just right above center a little bit in there. And so this is my guess at it. Okay. And then the ball, let's see, 1, 2, just short of 3. It looks to be right along this section line here. And what was the height? Oh, it was based on the cylinder. It was a little bit, the top was a little bit above the bottom where it hits the ground, and it was down a little bit below that. So I'm going to say that the ball, there's the height, I'm going to say the ball is something like that. So that's my prediction for the ball, right? And see, it basically it defined a little rectangle. Then you just draw an ellipse in that rectangle. So what's happening is that this curved surface is compressing the height of our cylinder and the height of the ball. But since it's a straight line across here in top view, it's not compressing the width as much as it is the height. Okay, it's curving more in this direction. It's straight in this direction. So there's a great lesson there, which is almost all convex positive curves will compress the reflection of the environment. So there's the ball prediction. Okay, and I said the horizon was slightly below the top of our cylinder. Let's just see how we did. Pretty close. Not bad. Okay, so it works. That's cool. That is getting you well on your way to thinking like a 3D modeling program, because that's what the modeling program is doing. So yeah, pretty close. And what about the reflection of the sky and all that stuff? We'll talk about that in the coming weeks, about the gradations, the colors, all that sort of thing, how to reflect the rest of the environment into it. Right now, this lesson, the most important thing is just to start to predict the big elements, like for instance knowing that everything up above here is going to be sky, everything below the horizon is ground, general position of the ball, general position of the cylinder. That's the big stuff this week. Okay, then we're going to talk about color, value, and gradations and all that stuff as we start to render in the coming lessons. Okay, this is our next scene. This is a part of a bigger curved surface, and it's in a